A number of people asked me this following the first exam, so I want to make it very clear. The best way to prepare for these exams is to first look at the existing exams that are available on the website. And once you finish those, then begin having a look at questions that are available in the book or doing homeworks. And in any case where you're unsure about your solution to a particular question, make sure that you code your answer to make sure that your solution works. A number of people talk to me about different ways that they prepare, and I find that the least successful way of preparing for the exam generally involves rereading the lectures and doing the labs and homeworks. Like that, the labs and homeworks are meant to give you specific programming experience, but the exams explore lots of other possibilities that you might not have thought of. So have a look at those practice exams because they'll allow you to explore a lot more possibilities so that you can't get surprised on the exam. Because as you know, the exams are cleverly designed to sort of get at all sorts of strange possibilities. Okay, so today we're going to be talking about one of the most subtle issues in this class, and it's an issue that I want to devote as much time to as possible because I find a lot of people get confused on it. And it's just one concept, but this concept throws a lot of people for a loop. And because it's very important, it is of course on the exam, but also more importantly, it's a source of tremendous, it's a source of many instances of bad software design. So I don't want you guys to be bad software developers, I want you to be good ones. And in that regard, it's really important to be able to pick up on this issue. Okay, so what we're going to talk about is pass by value and pass by reference with regard to methods. So methods are different from all the other containers that we've seen before. Methods have this kind of flexibility where you can write the method and have that code in this other container, and then you can call the method to get it to run wherever you need. And because they have this flexibility, we achieve that flexibility by having well-defined input and well-defined output. So because of this status of being a kind of a mini universe where the method has arguments as inputs and outputs, and because you can't change the inputs, we chafe at the different ways of using a method, and we try to use them very creatively. Because one of the things that we don't want to do is write a lot of similar methods that have basically the same code inside them. We want to reuse the same method again and again. One element of good software design is to always reuse the same code in flexible ways rather than having to rewrite similar code again and again. Because when we rewrite code that's very similar and we have to update that code, then mistakes that happen in one version don't always get propagated to the, or solutions that get made on one version don't always get propagated to the other version. And we don't want to have to do that kind of bookkeeping in our code, and so we avoid those errors by writing flexible code that has multiple uses. Okay. I want to skip some of these slides so that we can get to the meat of the question here. So in Java, we use the concept called passing by value. Methods in Java pass data into the method by value and not by reference. So there are two concepts I want you to be aware of. One is pass by value, and the opposite concept is pass by reference. So when you pass data by value, you are passing the value into the method for use in that value. You are not passing a reference to the original data. And that's why these two things are different. So one of the observations that you may have made, or maybe you haven't made yet, but I want you to make now, is that data can change inside a method, right? I can pass inputs into a method, and I can possibly change those inputs. And we want to use what happened to those inputs outside of that method. The exact process by which that happens has to do with how you call the method. But we have to be very formal about exactly how we treat each step of the inputs, because otherwise we lose track of what happens to the code. Okay, so let's look at this example here. This is about as simple example as I can make. So we have a really simple class. I'm not showing you the class structure. We have a main method in the class which declares an integer variable called x, and we print out the variable x before the call. Then we run this method called increment, and then we print out the value after the call. So inside this method called increment, we take x as input. So x is now called input in here. We add 1 to input. We say we increase the inputs. And then after the call, we print out x. Now, this is usually a point where I sort of call on somebody to say, like, what happens here. But I find that doesn't work, because then somebody who knows what's going to happen sort of ruins the surprise. But this is not going to be a surprise for some of you, and I want to make sure that everybody's on the same page. So rather than calling on somebody, I want to explain the misconception that can happen here, and then explain what actually happens here. So the misconception that can be had by some people is that when I pass in x and I add 1 to x here, that the value of x after the call to increment will be increased by 1. So the mistake, the misconception, is that when I print after the call, that it will print out x equals 2. The reason why that's a mistake is that because Java operates in a pass-by-value manner. It doesn't pass the variable into the function increment. It passes the value. If Java was a pass-by-reference language, as there are some older programming languages that pass by reference, then Java would pass the variable x in, and modifications to x would persist after that method. But Java doesn't do that. Java is passing the value. And actually, that's one of the reasons why I had this slight formality, like in our second or third lecture when I told you about variables, right? I taught you about how variables have an identifier and they have a value. They have a variable. And the identifier is just the name for the variable, right? And the reason why I made that distinction was because I wanted you to separate what the identifier was and what the actual value is. So what's happening here is that x is assigned this value in the main method. When we print out this line here, it says before the call, x is equal to 1. And when we make the call increment x, what Java does is it takes the value out of that variable. Because remember, the variable stores data. So it takes the value out of that variable and creates a new variable called input and puts that value into input. So now when it runs the increment method, it has this new variable called input. And input gets incremented by 1. So input is initially equal to 1 here. Input plus plus increments input by 1. And you print out, I increase the input. In fact, if you print it out here, I increase the input equal, quote, plus input, you would actually say 2. Because the value of input on this line is equal to 2. But input is never returned from this method. There's no way for input to escape from this method. Note that the method is void. So because this method is not returning any information, input simply stays in this scope. And when the scope is completed after the method is done running, all of that data is just deleted. It's sort of like this mini universe is now eliminated because we're done running it. And x still is the original value, because x had its value copied to run the increment method. X didn't have itself put into the method for change. Okay, So this is what actually comes out. Before the call x equals 1, I increase the input. After the call x equals 1. So what we could have expected if we had the misconception that I described, it would say before the call x equals 1, then it would say I increase the input, and after the call it would say x equals 2. This is not going to happen because of call by value. Question?
So in your method, instead of calling it input, you called it x as well, so that the same thing still happens as well.
No, it would not. So that's a great question. So the question is, what if increments was declared with the method variable int x? Then that would simply be a variable that's called x in a different scope that happens to have the same variable but actually is completely unrelated. So the variables having the same name in this case is only a source for potential misconception. It's actually not a source of linking the two things together. Really good question. I realize that this is a confusing issue, and it gets more confusing. I'm showing you the clearest possible rendition of this issue. So please interrupt if you have questions, because this gets more confusing. So let's look at this in a different way. Here's a schematic of what's happening. So I have sort of the mini universe of the method in this blue box, and you can imagine that outside of it I have the method. So inside the main method, outside of it I have the main method, not just the method, the main method. So in the black outside of the blue box, we have x assigned to 1. In a pass by value scenario, the value in x is taken out and put into the variable input. And then here it is manipulated inside the method. You increase it by 1, you print out increased, and then you output nothing. So the void is output. The output variable type is void. And when we print out the result, x is still equal to 1 because we copied x. We didn't actually change x. And some of the sources of confusion here can be the fact that, well, what if this was called x? So we know that if this is called x, then it wouldn't make a difference. It would still be a different variable, just it would happen to have the same name. And the other source of confusion here is the output, right? So I said the output here is void. So another common question that comes up is, well, what if the output wasn't void? What if the output was int? Or what if we returned input as opposed to just not returning anything? So even if we returned input, it wouldn't change the value of x. Because it doesn't matter what we returned. We'd have to assign the output of increment to some value. I'd have to say, like, int y is equal to increment. The only way that can cause x to change is if I said x equals increment of x, and I modified this to return an integer, and I also returned the input here. So that would basically force the modified value of input to be returned as an integer, and then stored into x after I ran this method. That wouldn't be because it changed inside the method. That would be because I deliberately caught the output and put it back into my variable x.
Can you explain what that means in a sense?
So void is the non-type. And it's only used in cases where you need a placeholder to say, I don't have one of these. So void in both of these places occupies the location where you declare the type of the output. So what we're saying with void in both of these cases is that neither of these methods produce outputs. So they don't have an output type. Or you could alternatively say that the output type is void. I'll say the same thing is not returning. So that's what void is. Void is a placeholder type for when you don't have the return. And you can also have void in the input, actually. You could have void here if you don't take inputs. And that would just mean that you don't take inputs. As you know, the exams and examples of bad code are designed to confuse you. And I haven't had a chance to say it this semester, but the reason why I have exams that are intended to confuse and intended to sort of get at misunderstandings is not only because I like to have tricky exams that help you learn the material, but because when you see bad code, you're able to recognize it if you've seen bad code before. One of the things that all of you that take on software development as something like an internship or maybe as a job later will do is that you will modify and work on other people's code. In fact, the vast majority of code that you write will not be code that you started with a blank file on. It will be code that you developed starting from somebody else's code. There's one aspect of commercial software development that is very difficult to reproduce in a class setting, and that's the case where you modify existing code. The reason why that is because, first of all, it's very hard to create existing code which has a certain kind of bug that you need to work on, and it's also very difficult to create these large banks of code and not have them get passed out and have the answers extracted and have that assignment completely defeated. So I'm going to have to rely on your imagination to think about these situations. And I'm supplementing that imagination with my own imaginary horrible code that you see in exams and in the examples that I give you here. So this is a great example of horrible code. And the reason why it's horrible code is because it's not wrong. This code works just fine. It's that this code stokes a misconception that the sloppy, inattentive reader might not pick up on. And therefore, a bug associated with the code might get overlooked. And as I said in the first lecture, one of the most difficult things about this class and about software development in general is that when you are looking for a bug to finish a project and you can't find the bug, you don't know when it's done until you've actually found the bug, right? The amount of time it takes to complete something is indeterminate. So this is a great example of something which is subtle, that you can easily overlook, that might cause you to spend an extra hour or two working on something, or an extra week or an extra month on a project working on, which simply leaves you anxious and worried about how you're going to finish the project. So let's look at why this has a misconception in it. And I like that you anticipated this particular bug, because this is a good thing to be aware of. So here we have a main method that declares a new scanner. Pretend that it's been imported up above and that there's a class around this. We take some variable x filled from data from the user, and we run this method called double entry on x, and then we print out the value double of x. Now, the bug here is the fact that double entry doesn't actually modify x. Double entry takes this variable, sets it equal to 2 times the variable, and then returns. But because this is a call by value language, this is because this is Java, x never gets modified, and so printing out x at the end results in no change in x. And so immediately when the user runs this code, it's going to compile. It's going to run just fine, except that when the user tries to print out the result, it's not going to be double the result. It's just going to be the same thing that they typed in. So you or the user will be looking for this bug, and the bug is a little bit hidden because this variable x here is not the same variable as this x here, because this method variable doesn't exist in the scope of the main method. It exists in the scope of the class method here called double entry. So because it has the same name, you might overlook the fact that it has a different scope, and you might think that this x here has the same scope as this, and therefore modifications of this x here carry over to this x in the main method, but they're actually two different things. They could have been called two totally different variables, and the code would run exactly the same. In fact, Java's internal representation of these variables, which is some number code, will have different number codes because Java knows they're different variables. It's just that it's easy for the programmer to get fooled because they have the same variable name. So I'm showing you this to inoculate you against this kind of error so that you'll be aware of this variable x and how its similarity with the x used in the exterior scope is just an unrelated similarity, an incidental similarity. In part because I want you to never get caught by this bug. That's also a strong hint that you might see this in the future, like on Friday. But you should also be aware of how this can come up in much more insidious ways. So I'm showing you the example that fits on one PowerPoint slide. Like I can create an example with these really short methods to make the error really glaring. But when you write long code that has many different methods in it, and only one of those methods has a variable with a reused name, and as you scan for that error, you overlook it. Every time you overlook it, that's extra time that you've wasted, right? Time that you could have spent being done with the project. So be sensitive to this, and think not just of the fact that you can have identical variable names causing trouble, but that these methods exist in separate scopes, and the only way for them to exhibit a change on the exterior scope is by returning a value. So the only way that something can happen in this method that can affect anything inside the main method or the method that calls the double entry method is for double entry to return an output, have that output be assigned to a variable. So the only way to have anything happen here is to change double entry to return an integer. And then say int y is equal to double entry, or assign the output of double entry to a variable, and then use that new variable for whatever you're doing. So I think when we first see methods, methods are a bit magical, right? Methods run something, and then the result comes out, and you can use that result. But the exact mechanism by which the inputs go into the method and the outputs come out of the method, that's a source of error and confusion. And I don't want that to seem magical at all. I want that to seem exact. So one way that I can make that seem exact is by also showing you what the alternative is to pass by value, and that's pass by reference. When I show you pass by reference, there's a risk that you may become confused, because now I've shown you the two things, and it's not clear which is one thing, which is the other thing. So let's be clear. When I pass by value, I use this term pass by value because I'm taking the value out of the input variables, and I'm putting them into the method. When I pass by reference, I'm taking the entire variable. I'm taking a reference to that variable and passing that whole variable into the method. And therefore, any changes to the reference to that variable result in changes to the scope in which that variable existed. So let's look at the differences. In Java, on the left, I have that schematic that I showed you where x gets passed in, its value gets translated into, or its value gets taken out of the x variable and copied into the input variable. Modification to inputs with no output results in no change in x on the exterior. Now, in non-Java languages, in pass-by-reference methods, I pass in x, and x is actually the value that gets modified. So in those non-Java languages, x is actually, or input is actually another name for x. It is a reference to x. So when I pass by reference, input becomes x, and modifications to input actually happen to x. And so I don't need to have an output here, and in pass by reference, x is modified on the outside. Now, we'll see a case in the third section of this class where we work with arrays. We'll see a case where Java can behave conceptually in a pass-by-reference way. And that's where things get even more confusing. So I want you to be very confident in your understanding about the difference between pass-by-value and pass-by-reference. And because later on I'm going to show you something that's going to make this even more confusing. Okay, so this is critical. The changes that you make inside that variable, those things all go away after the method completes. I think there's a tendency to feel like in any homework or any exam question that any change that you do must be for a reason. But in programming languages, sometimes the things that you do are for no reason, and you have to take special action in order to make sure that the changes that you implement actually are preserved. Yeah.
If you were to set, sorry, can you go back? This slide. If you were, sorry. If you were to, where's the one with the code? Sorry.
Oh, the code?
Yeah.
This.
Yeah, if you were, sorry, not that code. The one with the increment.
The original example.
If you were to set x equal to increment x, would that print x equals 2 the same time?
Yes. If I took if I made some modifications to this code, where I made increment return an integer, and I made this method say return input here, and I set x equal to the output of increment, then I would have the result from increments stored to x, and after the call would actually print out 2. So that's the way that I capture output. The only way that I can produce output from a method is by changing the output. Yes?
So like, is there a way to get around this kind of like scope issue? Like for example, like in the labs and homework, like if you declared like a scanner, like you said, like scanner, my scanner in one method, you'd have to do it in every method because you can't, like, even if you put it in the main method and then you tried to access it from another method, it wouldn't work. Like, is there a way to like make one scanner and then use it in all your methods?
That's a fantastic question. So yes, there is a way that you can make a scanner to use in other methods. And the way that you do that is that you make scanner an input to the method. And you might have to make scanner an output to the method if you change the state of the scanner somehow. But let's just say for an object in general, let's say not a scanner, but an object in general. People routinely pass objects in and out of methods, and they do that because they want to make some change to the object and they want that change to be preserved. It's sort of like, you know, I have a car in an assembly line, I want to add the tires to it. I have a method called add tires, and I want the thing that comes out of the method to actually be the car with tires and not the original car. So that change is achieved by passing those things in as output and taking them out, passing them in as input and taking them out as output. So if you wanted to have that change be persistent on scanner, you would pass in scanner as input and also have scanner be the output. There is one other way to get around this using variables that are essentially references in themselves. And I don't want to muddy the waters by talking about that yet. We'll talk about that before the third exam. The reason why I don't want to muddy the waters is this is confusing enough for people. And that complication only makes it harder. And I want to make sure that people master this preliminary idea first, and then we'll add the complication to it. Okay, so that was the purpose of this lecture. And every time I give this lecture, I feel like I'm not able to reach everybody. In part because, you know, not everybody is, you know, awake. It's 11, I understand. So if you aren't sure about this concept, please talk to somebody about it and try to understand it. Because the exam is on Friday, and in an ordinary situation, you might have more time to learn about this. In an ordinary situation where you were learning the programming language on your own, and you were trying to master this idea, you might have more time to absorb it. But this is coming on Friday, and on Friday, I won't simply ask you, like, what will incrementer produce? I will ask you a question that will be intentionally confusing. So my expectation is that you will master this idea by experimenting on it with code anywhere, by asking your graders and myself, and by thinking about this really carefully. Rereading this lecture will not be sufficient to deal with this particular issue, because this lecture just shows you the most basic example. And I want you to think about and look into the old exams to look for intentionally confusing examples, because that's coming. And I don't want this to be a source of confusion as it has been in previous classes. So whatever I can do to help you guys not be confused about this, I'm happy to do. But it's never the first lecture that's able to break that confusion in 100% of the class. Alternatively, though, I should hang the carrot out there that this is a classic interview question on sort of internship kinds of interviews. So when people try to get you on differences by call by value and call by reference, this is how they do it. So I'm not telling you stuff that's like, oh, Dr. Chen wants to create nasty questions, what a jerk. Like, it's really about having you be aware of one of the most important issues in programming. So follow up on this and ask questions if you have them. Ask questions on Wednesday, that's a great time. But ask questions to other people before then. And I guess I can just open it up for questions now. If you have questions about what you're working on or homework, sure.
In the second program of the homework, you said there should be 2 methods. Do you mean in addition to the method?
Yes.
Okay.
Okay.
I just have a question. When I put the last print line inside the method, and I assign the x to the value of input, would that something?
So just so that everybody can hear, the question is, if I took the last print line and put it inside the method, and I assigned x to input, or maybe I just put input in here, would that result in printing out after the call x equals the incremented value of input? And the answer is yes, it would. So the reason why I show these print lines here is so that we know in the scope of the main method exactly what's happening with x. And if we move this in here, of course, it's telling us about the scope of the increment method, in which input has a particular value, and that input does indeed increase the value. So, but that's important because that lets us explore what's happening in the increment scope and contrast it from what's happening in the main method scope. Christian, can you repeat that? Yeah. So the question was, what happens if I move this print line call into the increment method? So I guess it would be after this I increase the input call. So if I print out x at the end of the increment method and I substitute this reference to x here as with input, then the question is, would it print out the value of the incremented value of input? And the answer is yes, that it would. So if I were to put this up in here and change x to input, then it would print out after the call x equals 2. And that's because inside the increment scope, the scope in here, increment is a real value, input is a real value and has really incremented by 1. And everything is incremented by 1 inside the increment scope. After we leave the increment scope and we finish that command here and we come back to the exterior scope in main, the value of input doesn't exist anymore. Input as a value, as a variable, doesn't exist anymore. It's sort of like deleted out of the space of memory. So in that case, we only have x, and attempting to print out the value of x results in the original value. Yes.
If you return, let's say, like in that method, what would happen? Like, would it be assigned? Would it just like be assigned to input, or like that value?
That's a really good question. So the question is, if I returned the value, if I returned input at the end of this method, what would happen? Like, let's suppose we don't do anything else except.
But like, if it wasn't void.
Right. So if increment was not void and it returned an int here, and we said return input at the end of this, so it wouldn't compile if we said return input and this was still void, and it wouldn't compile if we said if we changed this into an int and then just said return or had nothing, because it would say that you had no return value. So if you say that you will return an int, you must definitely return it. Okay, so but if we made that change and we said, okay, make this void into an int and then return input here and make no other changes, what would happen is that increment would return this value input plus plus, so 2. And because it's not assigned to anything, that value is discarded. So that's what the importance of assignment in Java. When I assign a value coming out of a variable, or coming out of a method, I take that output method and I store it somewhere. And if I don't store it somewhere, then it's discarded. And that's really important because here I'm not making any assignment off of increment. In fact, you can't make assignment off of a void method. But if this was a method that produced an integer, I don't have to assign it. I can still just call increment and throw away the output. So if I didn't store it to something through assignment, I would just lose the value of input, and x would still not be modified. And that's partly why Anna asked the question, well, what if I store x equal to the output of increment in addition to that output? Only then can you catch the output. So you have to take the value of x and say x equals increment of x in order to catch the value.
And you can do that in the main method.
In fact, you have to do that in the main.
So you can return a value, and then if you set it, like say x equals increment x, then it would take that return value and set it to.
And store it into the x variable.
Okay.
That's right. Yes.
Is the only way that you would be using these methods to to increase your value by 1, or like could you do other things like multiplication and other like things?
Yes. So I don't only use methods to increase values by 1. That's just so we have a simple example. So I could have a method that was like calculate the area of this circle, or even a more complicated method that was like run this robot to install wheels on this car with all these parameters for the car's design and all that. So you can have really complicated methods that do really complicated jobs.
So how would you do, I guess, so if you were to do a multiplication one, could you kind of set it up the same way you do the addition with a multiplication sign instead, and kind of create an area or something like that? Or?
Yeah, so increment could be set up with 2 inputs. So it could be if I was going to do a rectangle, I could say, I could have a method that took int width and int height and returned an integer. And inside the method, I would say int result is equal to width times height, return result. And that would take the product of the two and return it as output. And once I assign the output of that method to some variable like area, at the end I could have int area equals rectangle area of width comma height. Then I would have the result from that method. Good question. Christian.
Can you go back to the side by side?
The side by side?
Yeah.
This?
Yeah, that. So if I wanted to make the pass by reference similar to the pass by value, would I end up putting a y equals input so that x isn't changed beyond that method? Yeah. So then it would.
Yes. So if you wanted to change a pass by reference language to behave like a pass by value language, you would deliberately make a new variable. I don't know, y is a good example. And you would do all of this stuff on y. And you would assign, inside the method, you would copy what was in x into y through assignment. And then you do all the calculations on y. And that way, x doesn't get modified. And in fact, in pass-by-reference languages, they actually do that sometimes. Like they're like, okay, well, here are the inputs, only take these ones that we want as values, do all the calculations, and don't modify the inputs because that results in problems. So I think a really good question that comes up in software design is why even have pass-by-reference or pass-by-value? Like why create these two things? Like if I'm the person designing Java or if I'm the person designing Python or whatever, like why make them pass-by-value as opposed to pass-by-reference? So the reason why languages were originally pass-by-reference is in part because they're easier to implement. If I pass in a variable, it's easy to just say, here, look, here's the location in memory where I'm storing that value. Use that value, right? Use that location in memory. And by pointing that method to that location in memory, it makes it easier to run the programming language. You don't have to make a copy of the data that's getting passed in. Making a copy of the data can get complicated in all sorts of ways that you don't want to deal with. The reason why a lot of languages moved away from pass-by-reference is because it can create situations that are unintended. So one of the things that we always want to avoid in software design is creating software where you can make a small change in one place and have a whole bunch of the rest of the code run differently, and run differently in ways that you don't expect or can't anticipate. Because that's how you create bugs, right? You make a small change and make everything else break for some reason. So pass-by-value prevents that because it just passes in a value and it makes the method like a sandbox. You can do anything you want in that method. You can write any code that you want in that method. But unless you pass the value out as an output, you can't blow up the rest of the environment. And this is really useful for teams working together because one of the things that will happen frequently is the project manager will hand out parts of the job to different software developers, and they will define the boundaries of the programming job based on exactly how the methods are defined. So, you know, if we're running a project where we're trying to suggest friends for people on Facebook, and we're overall going to have like a method that takes in, you know, your name and a bunch of characteristics of your account, and as a project manager, I want to hand out different parts of this job to people. Then I could say, well, okay, programmer A is going to take the user's ID and suggest friends by their family connections, and programmer B is going to take the user's information and suggest friends by their workplace connections. And you know, you can imagine that family connections and workplace connections, totally different methods that might have to be run. Like you can see that being separate jobs for people, intensive jobs. But if programmer A were to accidentally modify the credentials of the Facebook user by accident, then when you run get friends from family and get friends from work, and get friends from family messes up the credentials so that get friends from work doesn't work anymore, then that makes it hard for the team to work together because they have to coordinate really tightly. And that's frustrating. So call by value creates situations by making sandboxes where people working separately can't mess the same thing up. So any other questions? Okay, so I want you to think about this issue. It's a really important issue. And before we break for today, I want to talk about one more concept. So we have 5 minutes, and that other concept is overloading. Okay, so this is something that you should be aware of. And it's not as complex an issue as call by value, call by reference. But it is an issue that can come up. Overloading is when I have methods with the same name. This is a characteristic of Java and several other programming languages that is intentionally left in because sometimes we want to have methods that have the same name. So you might ask, like, why would you ever want to have methods of the same name? The reason why I want to have methods of the same name is because sometimes I want to do the same conceptual job, but I want to have different kinds of inputs. So I can have a sort that takes integers, and I can have a sort that takes doubles, and a sort that takes strings. And all these sorts might work on the same conceptual idea of changing the order of these variables or their strings, or so on and so on. But I don't want to give them a different name. Like, I don't want to make a variable called sort integers and sort doubles or sort strings. I just want to say sort. Overloading is a feature of Java that's designed to create this possibility for you. You can declare variables that have the same, you can declare methods that have the same name. And then you can use them. But then Java has to figure out what copy of that variable are you using. Are you using the variable that is the integers? Are you using the method that uses the integer inputs? Or are you using the overloaded method that has the same name that has the double inputs? You can see how Java has to work out what that issue is, because if you just say sort, it doesn't know what you're talking about. So, for example, I can have these different methods called getMax, and they can return integers or return doubles, or they can take integers as inputs or doubles as inputs, and so on and so on. So Java has to decide when it runs getMax exactly what's going to be called. So if I have this example here, basically I've got int getMax and double getMax. It has to figure out when you run getMax what exactly is going to happen. The way that it figures out which method is going to be called is by looking at the types and look at the number of variables also. So if you have two overloaded methods with a different number of variables, then it's going to figure out based on the number of variables which method you want to call. But if they have the same number of input variables, it's going to look at the types. So so the way that it's going to decide is it's going to decide, can it implicitly cast values of one type into the appropriate implemented method that it has. So I want you to think about overloaded methods. We don't have too much time to talk about them today, but I'll answer questions about them on Wednesday. Overloaded methods are a great way to make things easier, but they're also a great way to make confusion. Yes?
So if under lectures, like the last one, have I this exam?
This is the last one, so 16.